Okay, so now we're going to talk about kind of the nitty-gritty mathy aspects, the mechanics behind neural networks. Now, it's not that complicated. We're going to use some, addition, multiplication, a little subtraction maybe, but we're not going to be taking any derivatives or, there's no trigonometry or geometry involved. It's going to be pretty basic, okay? So I realize that some students have math anxiety, and I would just try to work past that. Okay. Please watch these videos. So, with that being said, here we go. So, here is what we have right here is we have a neuron, right? And this neuron is an artificial neuron, of course, a node that's receiving activation from n different nodes. So, this is an input node, I1. This is input node 2, input node 3, all the way to input n. Okay, that's just the number of nodes. And each one of these inputs have a weight associated with it, a connection weight, okay, which again is going to determine the speed with which that activation gets spread to the receiving neuron, okay? And so what happens is you might be asked, so the question is, does this neuron fire or not? And the question rests on two things, right? The total input to neuron X, so the amount of activation it receives from other neurons, as well as whether that activation is greater than a threshold, okay? Some threshold. And so uh, if you look here, right, this is a really this seems like it's complicated, but it's not. Okay, it's essentially saying, hey, let's take this input, weight it, right? Weight it, so multiply it by this weight, right? And do that for each one of these inputs. And then once you're done doing that, multiplying, then you sum them all up, and that gives you the x. It gives you a certain a value of x that's represented by x. And this is essentially the activation, okay? The activation of that neuron. And the question is if that activation is greater than some sort of threshold, then the neuron fires. However, if the activation is less than the threshold, then the neuron doesn't fire. And that's basically it. So I'm going to show you, I know that, everything should make sense, right? Right? Okay. So we're going to do another example with actual numbers, a concrete example. So hopefully, if it doesn't make sense now, hopefully in this next slide it'll start clicking a little bit more. So here's and basically the same thing as before, except now we have values associated with each input unit as well as each weight. So here we have the first neuron has an activation of 1, which means, so then J equals 1. So if J equals 1, that means it's the first input unit. Well, what we do is we multiply that activation, which is 1, by the weight, which is 0.02. That gives us an activation of 0.02. So that means that 0.02 activation got sent to this neuron by this neuron. Okay. And then for J2, now we're on the second neuron here. The input the input for that neuron is 0. So we multiply 0 by the activation of 0 by the weight, which is 0.1. That gives us an activation of 0. We do the same thing for J equals 3. So J equals 3. Now we're just talking about the third neuron. The third neuron has an input activation of 1, and it gets multiplied by the weight, which is 0.06. So we have an activation from that neuron, which is 0.06. And then what we do is we just sum them all up. That's what this little this little summation sign. This is a summation sign. It says sum up these weighted activations from j equals 1 to the last j, right? So j1, j2, j3, add them all up, we get an activation of 0.08. So our total input for this neuron is zero point zero 0.08. Now, zero point zero 0.08 is very small, okay? So zero point zero 0.08 is probably going to be less than the threshold, okay? So in which case it doesn't fire. Okay, in the next video, we'll talk a bit more about the nitty-gritty details.